Introducing the SwiftUI framework. In this reference guide, we will learn everything about the latest improvements and features of Apple's native user interface framework. But before we dive into the details, I would like to highlight the major requirements so you can follow along with me. Apple Developer. Also, you can get more information about app development and all the necessary tools at the following official website: developer.apple.com. XCode. First and foremost, you will need XCode application installed on your computer. To get the latest version of XCode, you will need to open the App Store on your computer and download it using your personal or business Apple account. It's worth mentioning that XCode editor is free, which is fantastic. Also, the yearly membership in the Apple Developer Program is not required to get started developing applications. However, if you want to publish your apps to the App Store, then it is highly recommended. Please notice that since the file size of XCode is enormous, therefore it will take some time when the download is done. While XCode is downloading, you can continue watching the rest of this video. iOS 15. Another requirement is the latest operating system, iOS 15. That's why when you create a new SwiftUI project and save it into the Students folder, then you must make sure that the deployment target is iOS 15 or newer. You can check it out by selecting the main project on the Project Navigator pane on the left side of XCode, as I show you. By choosing the correct iOS version, we will be able to use the latest and greatest of the SwiftUI framework. App icons. If you are like me, who like developing great applications with high-quality design, then I have good news for you. Each project in this section is providing you the necessary resources such as app icons, graphic files, and occasionally other media types, like videos, music files, or sound effects. With that said, you can add these assets to the project and make your app look and sound better. In the rest of this introductory lecture, I will show you how to do that. We will start with adding the pre-made app icons to the project. First of all, select the Assets group from the redesigned Project Navigator pane as I do. After that, you will see the empty app icon asset catalog in the middle pane. A new contextual menu will show up by control-click or left-click on this app icon asset. From this context menu, please select the Show in Finder option. This is the place where we will insert the pre-made app icons. Please open a new Finder window in the tab bar and go to the Resources folder that you previously downloaded from each section. Here, we need to open the App Icon Set folder and copy all files in the folder to the clipboard. When we are done with it, we can switch back to the Assets catalog and paste the icons from the clipboard into the App Icon Set folder, as I show you. Please, select the Replace option if needed. After all of these steps, you should see the recently added app icons to this project. How cool is that? Other resources. Finally, if you find other files in the Resources folder, then you just need to drag and drop them into the Asset catalog as I do. It is as simple as that. Testing. Now, with all this prep work, you can start coding along with me and get familiar with all new exciting SwiftUI features. Of course, when the time comes, we will need to test our project. To do that, we can either build then run it in the simulator or on a real device that has got the latest iOS or iPadOS installed. To make this happen, the only thing that we need to do is to select the desired destination from the toolbar. By clicking on the scheme selector, a new drop-down menu will appear for us. Please select one of the available simulators, then build and run the project by clicking on the play button on the toolbar as I show you. After the initial launch, we can read a welcome message on the screen. It couldn't be easier to start developing in XCode in my opinion. Since you got all the necessary information on how to create and prepare each project in this section, then without further ado, let's open XCode and start learning. In this SwiftUI tutorial, we will learn how to load and display an image asynchronously from the internet. Note that the SwiftUI async image view uses the shared URL session instance to load an image from a specified URL and then display it on the screen. Until the remote image loads, the view displays either a standard or a custom-built placeholder. To gain more control over the loading process, we can use the initializer, which takes a content closure that receives an async image phase to indicate the state of the loading operation. By doing that, we can control what to display on the screen. In a nutshell, we can return a view that's appropriate for the current phase, such as success, failure, or empty phase. Alright. Without further ado, let's create a new project in XCode and start coding. Basics. The simplest way to use async image is by specifying the image URL. To do that, first, we need to create a new property that will store the web address of the image in a string. Enter this code. Private. Let image URL string equals https://credo.academy/academy@3x.png. After that, we will replace the default text view with the simplest form of async image like this. New comment, mark. First, basic. Then enter this code. Async image. URL. String. Image URL. With this short and quite straightforward piece of code, we can download and display a remote image. The first thing you can notice on the preview is a gray placeholder. The reason behind it is since the URL is optional. Therefore, the async image will show a default gray placeholder if the URL string is invalid. And if the image can't be loaded for some reason, for example, if the user is offline or the image doesn't exist, then the system will continue showing the same placeholder image. That said, let's see what will happen when we start the live preview. There it goes. Once the remote image is completely downloaded, async image displays this image in its original size. You know, I uploaded this huge image to the server for you on purpose so I can show you how to scale it down. The scale parameter. To make it happen, first comment out this line of code and start a new section by entering this code. New comment, mark. Second, scale. Async image. URL. String. Image URL. Scale. 3.0. And that's it. We can see the whole image and not only part of it. If we want to make the image smaller or larger, then we need to pass a scaling value to the scale parameter like this. The default value is always 1.0. The greater the value is, the smaller the image is. That's why the 2.0 and the 3.0 will scale down the image. Conversely, a value less than 1 will make the image bigger. Let's try to change the scale value from 3.0 to 2.0, and let's see what will happen, shall we? As you can see, the image scaled up a little bit. Now let's check out the remote image with the default 1.0 before scaling back to the ideal size. From now, working with different image sizes shouldn't be hard since you know how this works. Custom placeholder. Alright. Now let's jump to the async image's next feature, shall we? Async image provides another constructor for developers if we need further customization. Comment out the previous line and enter the following code. New comment, mark. Third, placeholder. Async image. URL. String. Image URL. image, in, image, placeholder, image, system name, photo, dot, circle, dot, fill, padding, 40. As you can see, we have just added a tiny icon as a placeholder for this async image. Now with this initializer, we can also use the content and the placeholder parameters to manipulate the loaded image. For example, we can add some modifiers to make either the remote image or the placeholder resizable. Let's do it right now. Enter the following code. Image. Resizable. Scale to fit. Then add these new modifiers for the placeholder as well. Image. Resizable. Scale to fit. Frame. Maximum width. 128. Foreground color. Purple. Opacity. 0.5. And there is a customized placeholder. What do you think about it? It's pretty obvious that our own implementation for the placeholder is much better than a blank gray sheet. However, we must keep in mind one important thing about these modifiers. We cannot apply image-specific modifiers, like resizable, directly to an async image. Instead, we must apply them to the image instance that our content or placeholder closures get when defining the view's appearance. So far, we covered how to create a basic async image, and then we scaled it appropriately. Finally, we learned how to add a custom placeholder for it. We discovered a lot, but not everything, since there is still one more thing that we should learn about the async image. Image extension. But before we continue developing this mini application, we should hold on a second and look at our recent code. As you can notice, we added many modifiers for the image, and since we will create a new async image, therefore we need to repeat this code, which is not so fun after a while, to be honest. But not only that, there are already some duplicated modifiers in this code as well. It would much better if we could optimize these modifiers somehow. And that's what we will do by creating a reusable image extension. First of all, select the image's modifiers and cut them out to the clipboard. After that, we need to navigate the cursor outside the scope of the content view. Scroll to the top and enter the following code. Extension. Image. Func. Image modifier. SumView. Self. Here we need to paste the modifiers from the clipboard, as I show you. So far, so good. Now we will continue with creating another function for the placeholder's modifiers. Enter this code. Func. Icon modifier. SumView. Self. Image modifier. Please notice that we have just embedded the previous modifiers into this new one. How cool is the Swift language? After all this, we need to cut and paste the remaining modifiers in the placeholder into this image extension. So let's do it. Now it's time to add all the necessary image modifiers to the image and placeholder again. Go to the image and enter Image. Image modifier. Then jump to the placeholder and add this one to it. Image. Icon modifier. Nothing changed in the preview, which means that our code works as it should do. However, our code is much cleaner now, not to mention that we can use the image extension over and over again. Async image phase. Now the fun part begins. Select all code in the third section and comment out as I show you. Then let's create a new section for the async image phase. Enter. New comment, mark. Fourth. Phase. Then we need to create a new async image with a different constructor. Start coding. Async image. URL. URL. String. Image URL. Phase. In. To gain more control over the loading process, we need to use this new initializer, which takes a content closure that receives an async image phase to indicate the state of the loading operation. Also, we should take into consideration that this will return a view that's appropriate for the current phase. And these are the phases. Success. The image was successfully loaded. Failure. The image failed to load with an error. And finally, the empty phase, when no image is loaded. Now, let's see in action how we can work with these async image phases, shall we? Enter the following code. If let image equals phase dot image dot image modifier. Else if phase dot error not equals to nil. Image system name ant dot circle dot fill icon modifier. Else image system name photo dot circle dot fill icon modifier. Padding 40. As you can see, the async image view provides another constructor if we want to take more control of the asynchronous operation. That being said, we can display different images in each distinguished phase, such as the success phase, then the failure phase, and finally the empty stage. But enough with the talk, and let's see how this works by using the live preview. After starting the live preview, we can see the remote image replacing the placeholder image. So far, nothing new here. But this will change once we modify the image's URL. So that way, the app could not load the remote image anymore. For example, we can remove a letter at the end of the string, and voila! By refreshing the live preview, the URL session's new response will be a failure. That said, this icon with an ant will represent the failed content on the screen, replacing the placeholder image. How fantastic is that? Of course, we can play with it for a while until we check out how all three async image phases work. By the way, it is not the only way to use async image phases. In the rest of the SwiftUI tutorial, I will show you an alternative mode of doing that. However, to make this more interesting, we will add some animation to this async image and make it really cool. Animation. The process is the same. Select the fourth section code and comment out as I show you. After that, let's create the final section and make the best of the SwiftUI's async image. Enter the following code. New comment, mark. Fifth. Animation. Async image. URL. String. Image URL. Phase. In. Padding. 40. So far, the code is identical to the previous one. However, we can utilize the async image phases enums in this new sample code. Let's do it right now. Enter the following code. Switch. Phase. Case. Success. Let. Image. Image modifier. Case. Failure. Underscore. Image. System name. Ant.circle.fill. Icon modifier. Case. Empty. Image. System name. Photo.circle.fill. Icon modifier. As you can see, we used the switch statement instead of using the traditional if-else conditional. The reason behind this is the following. The async image phase is actually an enumeration that keeps track of the current phase of the download operation. Knowing this fact, we can provide a detailed implementation for each of the phases, including the empty, failure, and success phases. This code is so elegant, am I right? Just one more thing. As you can notice, there is a gently warning that the compiler gives us. You know, this code works totally fine since we covered all available phases. Yet, we should make our code more bulletproof and less error-prone. Click on the warning sign, and read what the compiler is saying about it. There it goes. Basically, software engineers at Apple could introduce more phases for the SwiftUI's async image in the future, and that's why we can avoid potential app crashes by providing a default value. By clicking on the Fix button, XCode will help us with inserting the missing code. Do you see the new code at the end? Just replace the fatal error with a simple progress view. That's it. Now let's start the live preview and test the application. Guess what? The warning is gone, and our code works as it is supposed to do. The only thing that is still missing the animation feature that I promised you before. To animate the remote image, we need to specify an optional transaction parameter for the async image. Navigate the cursor to the URL parameter and enter the following code snippet. Transaction. Transaction. Animation. Spring. Response. 0.5. Damping fraction. 0.6. Blend duration. 0.25. With this transaction, we defined what kind of animation we want to run each time when the image downloads from the internet. The final information that we still need to provide to work this animation is some type of transition. And oh gosh! There are plenty of transitions that we can choose from. In the rest of the tutorial, we will have some fun playing with some of the available transitions. Does it sound good? I hope so. So let's do it. Go to the image and add this new modifier to it. Transition. Move. Edge. Bottom. After that, let's refresh the live preview and see what's happening. Whoops! What a surprise that animation with async image does not work in the preview. Don't worry too much about it, since testing animation is always better on an actual device, even we could do it in the simulator. With that said, build and run the application in the simulator as I show you. After the initial launch, we can see the picture icon in the empty phase, which works like a placeholder. When the remote image is downloaded, then the chosen animation starts. Now let's try out a different transition, shall we? Jump back to XCode. First of all, comment out the move transition, then let's add a different modifier to the image. Enter. Transition. Slide. Of course, we need to build the app and test the slide animation in the simulator, so let's do it again. Depending on the language writing direction, the remote image is sliding into the middle of the screen from the left or the opposite side. What an amazing animation that is! Let's test it again. But you know what? Let me show you my favorite transition. Jump back to XCode and replace the previous image modifier with this one. Enter. Transition. Scale. If you test the app on a real device or in the simulator, then you should notice how great the spring transition fits this scale effect. I hope that you like the final results so much as I do. With building this mini application, we covered all features of SwiftUI's async image. From iOS 15, no third-party plugin is needed if we would like to load remote image assets from the internet. Wrap up. Just to recap the main features of this dedicated async image view. To load an image from the internet is as simple as providing an optional URL for the async image. Next. By default, the image is assumed to have a scale of 1, meaning it is designed for non-retina screens. We can change it by modifying the value of the scale parameter. Another thing is that we cannot apply image-specific modifiers directly to an async image. Instead, we must apply them to the image instance. It's worth knowing that we can specify a custom placeholder and replace the default gray view. Finally, we can also utilize the enum of the async image phase in the content closure. With this async image phase, we can indicate the state of the loading operation. And by doing that, our program returns a view that is appropriate for each phase, such as empty phase, failure phase, or success phase. In this SwiftUI tutorial, we covered many code examples of how to use the async image properly so you can implement this knowledge into your development workflow. I hope that you enjoyed this lecture and you are eager to start the next one. Until then, happy coding!